Okay, so Blanchett, what was your issue?
What?
Did you have an issue? You said you didn't know how to do a problem?
Oh, yeah, I got the wrong answers for, number 4.
Which one?
Number 4.
Number 4. Okay, I'm gonna leave this here because I'm gonna use this in a minute, but I'll put number 4 over here. Okay, so what's going on in number 4? Looks like we have pi over 6, 5 pi over 12, 2 pi over 3. Okay. All right, I hope I do that somewhat correctly there. We are, what are we doing? Writing a cosine equation for this? Okay, so first of all, let's figure out just the basics. Where's the midline of this? You cannot tell from mine, but you can on your homework there. This is number 4. Where's the midline? Looks like it's at negative 3. Okay. And what does that make the amplitude then? The amplitude would be 4. And what else are they? Period. What's the period of the thing? Pi. And that's kind of an easy one. That means your B number, remember period is 2 pi divided by B, so the B number must be 2. So when I write my cosine equation, I already know the amplitude's 4. I know the period's 2, and I know the midline or vertical shift is negative 3. So that much of it, and I might as well go ahead and do a sine equation too. All that part's going to stay the same, right? So now I just have to figure out, okay, if I'm doing a cosine curve, where do cosine curves start? At the maximum, right? So I have a choice here. I can either start it at this one. Do I have that point labeled? I do, negative 7 pi over 12. So if I choose to start there, then this would be x plus 7 pi over 12. Or I could start over here, is that 5 pi over 12? And in that case, it would be x minus 5 pi over 12. They're both fine. They're both equations of cosine curves. Now, if I want it to be a sine curve, then I need to start it on the midline. So maybe here. Is that pi? I don't know if that's my picture. I don't trust it. Pi over 6. So I could say x minus pi over 6. And that would be a sine curve. I could also, well, that's going to be my favorite because I really want to keep a positive one. There are tons of different equations we could write, but that's that. Okay, Luke, does that make sense to you?
Yeah.
Okay. All right. So that kind of is a good lead-in because next class, which is at tomorrow, we will have a little quiz, very small, where you are going to be doing exactly what we just did. Okay? So, I just randomly made one up here, your picture. And we're going to write a cosine equation and a sine equation for this picture. So, I didn't know we were going to do that homework problem because this is exactly what we just did. So, where's the midline? 1. So our midline is at 1, so our vertical shift, I'll just label it here, y equals 1. Making our amplitude then 2. And our period is, maybe from here to here, you can check the period. What is that? 4 pi over 7. So if the period is 4 pi over 7, and period equals 2 pi divided by b, then 4 pi b equals 14 pi, and it looks like b equals, is that 7/2? So without really anything, you can build most of your equation. So 2 sine 7/2 plus 1, or 2 cosine 7/2 plus 1. Is everybody okay with that? So now we just got to figure out, okay, where am I starting? Well, if we do the sine curve, it has to start on the midline, right? On some midline point, it has to start. So we're going to start right here, a nice little positive sine curve, which means this is going to be x minus pi over 7. Now, if it's a cosine curve, it has to start at a maximum or a minimum. Now, I know I told you try to keep it positive, but this one, if I start here, then I have no phase shift, right? But if I start there, I have to remember to put a negative out here because I'm starting at a valley instead of a peak. If I want to keep it positive, and again, there's no rule that says that. That was just me begging for your help. Then I got to start here, right? That would be a positive cosine, and that would be x minus 2 pi over 7. Julia?
When we're writing C, like on the homework, like not in the equation, do we have to include, would it be a negative pi over 7, or would C just be pi over 7, but in the equation?
In the equation, the equation, the format he's using in the equation is, so it's C, okay? So it's not the phase shift. The phase shift is the opposite of C, the actual phase shift.
So for C, we just write the number?
Wait. Mhm.
Okay.
All right, okay, we good there? Okay, so now we're going to take a look at the next thing in our notes, which is 3/7. And then we'll be having a bigger quiz after we get done with 3/7. Tomorrow you're just gonna write an equation for me, make sure everybody knows how. Okay, so we all got here except Anna. Is that right now? Okay. All right, so here we go. Happy Valentine's Day, everyone. I didn't realize that there wouldn't be another Ash Wednesday, Valentine's Day for 140 years. This is a special day. It only happens that seldom. All right, example 1, notes 3.7. The graph is given in the XY plane. What is the period? Okay, this should not be a hard question. What is the period of that picture of F? What? 2. Yeah, 2. Easy. Okay, let G be this function. Which of the following could represent the constant C? Well, it's a cosine curve. So technically, there wouldn't even need to be a C, right? What do you think? Why isn't it 0 then? If there doesn't need to be a C, how come 0 isn't the answer? There's no negative. It's upside down. So if we have a positive amplitude, or a positive A, which we do, 1, which one is it? Pi over 2. Yeah, the phase shift, pi x plus pi over 2. If you put pi over 2 in, what would that do? Shift your picture pi over 2 to the left, which is exactly what happened in there. Good work. Oh boy, one of our favorites. Here we go. Take a minute and read example 3, see if you can figure out what's going on. I'm gonna just try to figure out some points here so I can figure out what's going on. Remember now, my points are what? What do they represent? What is my x coordinate representing? The x coordinate of the position. So this is the x coordinate of the position. And time, oh no. This is time, and this is the x coordinate of the position. Okay, you can model the x coordinate as a function of time. Okay, so at time 0, what is the x coordinate of the position of the yo-yo? 0. Now, if you're saying no, it's negative 30, stop. What's the negative 30? That's the y. And we are building a function where our coordinates are time and x coordinate. Okay. Now, well, there are a lot of points I could list. Let's back up a minute. At time 5, the yo-yo has completed 20 rotations. So what does that tell me? Every second, I make 4. Okay, so 1 rotation would be a 1/4 of a second. So at a 1/4 of a second, is the yo-yo right back where it started? So I'm gonna go ahead and plot those 2 points. So I got 0, and then I've got 1/4. 0. Okay, well, right in the middle of that would be an 1/8. Where's the yo-yo at that point? I should say, not where is it, but what's the x coordinate at that point? Well, where is it on your picture? Here's where it is at 0. And here's where it is at a 1/4. Where is it at an 1/8? Up at the top. So the x coordinate is still 0, but it's 0 up here, not down here. Okay, well, where is it? Let's see, this would be 1/16. Where is it at 1/16? At 30? Because at 1/16, kids, wouldn't it be over here on the right side? That's 30. Well, where is it 1/16? Where is it at 3/16? Negative 30. Because at 3/16, it's around here, 3/4 of the way around. What shape is that? I connect those dots, what have I got? Nice little sine curve. With an amplitude of 30. No phase shift, no vertical shift. What's the period of this? So 2 pi over b. So it looks like b has to be 8 pi. So which equation matches? D. D. So again, pay real close attention to these word problems, what x and y actually represent. We know this point right here, that's the yo-yo, goes around in 1/4 second. Would everyone agree with that? So here it is at the beginning, and here it is at a fourth. So t equals 0, and t equals a fourth. So this is where it would be t equals an 8, halfway around. This is t equals half of that, and this is 3/4 of the way. Does everybody understand that? Those are the times and locations. So then we just want the x coordinate. So at 1/16, the x coordinate is 30. At 1/8, it's 0, negative 30, and back to 0 again. That's where these points came from. Okay, does that make sense? All right, number 4, we have another clock mounted on the wall. Writing the whole equation, guys, you're only coming up with what the amplitude and the vertical shift. So 0.70 is a max, and 30.52 is a min. Yeah. So what do we want to know? What is the amplitude? What is the vertical shift? Well, where's the midline? What's halfway between there? 61. So D is 61. And if that's 61, what's your amplitude? 9. So A is 9 and D is 61. Everybody okay? Just for fun, let's go ahead and write the equation. He didn't ask you to do that, but let's go ahead and do it. We already know part of it. So 9 cosine something plus 61. All right, so we already know that much. Do we know the period? First of all, it's a clock, and we're talking about the minute hand. So the period's going to be 60. And that makes sense, doesn't it? Because this is half a period. So the period's 60, which means 2 pi divided by b would be 60. So are you getting pi over 30 as your b? If this is a cosine, oh, he's got a sine on there. I'll start with cosine. If this is a cosine curve, then what kind of phase shift do I have? None. So I don't need that space. That's just it. It's cosine. What if it's a sine? Well, remember, all this stuff stays the same. All that stays the same if it's a sine. But if it's a sine, this picture is really bad, but if it's a sine, it would have to start on the midline, right? Now, if you started it here, which would be where? 15? If you started it there, which is fine, this would have to be negative because you have your valley first. Now, if you started it over here, what would that be? 45. And then you could get away with a positive. Started here. Are they okay with that? All right. What's next? All right, let's take a look at example 5 and see if you can figure this out.
How do you know that it's 15 and 45?
How do you know that what?
That the x values are 15 and 45?
Because everything about a sine and a cosine curve is symmetric. So this is the midpoint of that, that's the midpoint of that. So it's halfway between 0 and 30. Remember, when you graph the pieces, and I'm gonna talk about the pieces, increasing concave down, decreasing concave down, decreasing concave up, increasing concave up. When you graph those pieces, they came right off the unit circle. They are quadrants. They're equal. Okay, are you reading example 5? What's going on there? There's a hideous looking equation. There's a lot of words. But the question is dealing with a maximum or a minimum, right? That's all. And in a sine situation, isn't the maximum just going to be located an amplitude above the midline? And a minimum the same thing, only it's an amplitude below the midline? So where is the midline in this problem? 61.2. What is the amplitude of the problem? 25.7. So won't a maximum be 86.9? And a minimum be, this is challenging, is that right? 35.5? So do any of those work? C. The minimum average monthly temperature is 35.5 degrees. Okay. All right. Now, the next one. Read the question. A sinusoidal regression. Get your calculators out. We're going to do a sinusoidal regression. So you know how to read this. First of all, please do make sure that your calculator is set in radians. So go to mode and make sure radians is highlighted, because all of our work is done in radians, remember? So make sure you're in radian mode. Then you'll go to stat edit, just like always, and put in these points. So stat edit, here you go. L1, L2, get them in. Okay, then you know what to do. After you get them in, you go back to stat. But now we go over to calc, right? Now go down the list until you find the one that says sign. Now, I don't know about the new calculators, mine only does sign. But we've talked about if I need a cosine, it's easy to get that, right? It's easy to go back and forth between them. It's just a phase shift issue. So we're gonna get a sine equation, so do the regression, so sine, regression. And always, like with all your regressions, the calculator will give you the way it's setting up its equation. So this is a little different than the way Mr. Passwater's been setting them up. And that's okay, we can handle it. But does everybody notice, this is the way your regression is set up? So, y equals 3.118 sine 0.570x plus 0.913 plus 8.208. How does that look to everybody? Is that what you got? Okay, so what do the directions say? What is the maximum number of nighttime hours predicted by the sinusoidal function model? Okay? I think he's got a mistake in here. Because how would we find the maximum? We just talked about it. Midline plus amplitude. So midline, 8.208. Is that right? Plus amplitude, 3.118. I got 11.326, which is not an answer. So what I did, when I was looking through these yesterday, I said, okay, well, something's fishy. So I went ahead and graphed this equation and literally used my maximum button to find the maximum, and it's this. So I think he just has a mistake in his choices.
With the, what's it mean when it says with 16 iterations?
I think what he means is, they did this data was collected over like more times, but that doesn't really matter to us, does it? Because I don't have any more data points.
But when we put it in calc and we hit it in sim regression, it gives us like an iteration button that says 3. So we need to change that to 16.
Oh, mine doesn't do that. Mine doesn't do that. So yeah, go ahead and change it, then that would be the difference.
Yeah, it's like it's close to it.
That would be the difference. So when you hit, calc and go down to that, you get that option. See, I don't get that. So those of you that have that capability, do you see what he's talking about? I don't even have it. I need to look at it. That's what he's talking about. You gotta have a calculator every day. See, I don't have that. Thank you for pointing that out. Okay.
It doesn't change the numbers too much though.
But
I
it
don't think
probably
it's,
changes it enough, maybe to get one of his choices.
actually, I don't.
Yeah, it's just 11.3.
I think he's got a mistake on there. But yeah, thank you, Xander, and everyone for pointing that out.
What is the 60?
Hmm?
Like they did it 60.
Yeah, it's just repeated. Okay, perfect. Thank you, that's interesting to know. Okay, those of us with the old time calculators, we're just gonna have to go with whatever it comes out. And hopefully they're grading this. All right, we got a couple more minutes left, we're gonna do a little more, but first, it's time to talk about our spring semester paper. And I love what Father Jeff said right at the end of Mass, because that's what our paper is about. So, once again, one page, minimum, one page typed. Then do it, turnitin.com, just like before. But here's what you're gonna do. You're gonna pick something, hopefully you'll all do this, pick something small that can help someone else. So for example, clean up after dinner one night a week. Do the dishes, put stuff away, take that off your mom or dad's plate. You do it, you take care of it. Help your little sibling with homework a couple nights a week. Go visit a relative, like a grandmother or an aunt or someone who doesn't get to see you very often. Go visit them every Sunday afternoon. But I want you to pick something small, okay? It doesn't have to be, go grocery shopping for your mom. Mom, give me the list. Every Thursday you go to the store. Or every, I don't know if your family does, you know, fast food, you'll go pick it up, or whatever, on a regular basis. So this isn't a one-time deal. This is something you're going to do repeated times, once a week, twice a week, during Lent. And then you're going to write about how what you did impacted the other person. How did your mom react when all of a sudden you started vacuuming a couple times a week, or whatever? And then how did it impact you? Okay? So paper's due on the 27th of March. So Good Friday is the 29th. Friday due the Wednesday before. So, like 6 weeks from today. So you have, or maybe, I think it's 6 weeks after today. So you have time to think about what you want to do and then do it a few times, okay? And then write about it. I don't have all the stuff posted to Schoology yet because I don't have all the codes for Turnitin yet. That takes a while, especially for me because I only do it a couple times a year. So as soon as I get that done, I'll get that posted to Schoology. But I want to tell you about it now so you can start thinking about it. You don't have to be Catholic. This isn't a, I mean, it is a Lent thing, but it isn't a Catholic thing. You are helping someone else. And you don't have to be Catholic to help someone else. If you really have an opposition to this, no, Ms. Ford, I'm not going to do that. Then come see me and I will come up with an alternative assignment for you. But quite honestly, who wouldn't want to help somebody else, especially someone you love, like your mom or dad or someone, right? Okay. All right, that's the paper. We're not packing up yet. We still have a few minutes and we have to use every single minute. So, let's look at the page called, it's the back of the page called It's Getting Hot Out Here. We're looking at the check your understanding on the back side. Check your understanding. Alright, Patty decides to ride Ferris wheel. She's got the equation for her distance above the ground. Why does it make sense that her distance above the ground is modeled by a sinusoidal function? She's going up and down and up and down, right? Around and around and around. Perfect. Estimate her height above the ground after 5.5 minutes. Don't make it hard. What are you going to do? You're just going to put 5.5 in for t. So negative 20 cosine. What'd you get? It's really important that you close the parentheses before you add the 23. Okay, what'd you get? 30.654. Right, we're in rounding to the thousandth mode, so 30.654 feet, good. What is the maximum height that Patty is ever off the ground? 43? Okay, so again, this is like the fourth time we've talked about this today. Maximum is midline plus amplitude, so that would be 43, and then her minimum distance off the ground is 3. How come it's not 0? Because, have you ever been on a Ferris wheel? You're not sitting on the ground, right? You're up a little ramp or steps or something to go on the board. What's the diameter of the Ferris wheel, and how do you know? 40, and how do you know? Because she went up 20 and down 20. And how long does it take the Ferris wheel to make one complete revolution? That would be its period, right? And how do we find period? 2 pi divided by b, and in our problem, b is pi over 4. So 2 pi divided by pi over 4 is what? 8? So how long does it take? 8 minutes. That's a little time. All right. What does the clock say? Actually, I think I'll stop there, because you're all looking at the clock, and it's time anyhow. So we'll pick up there tomorrow after we take our little tiny quiz.